The lesson outcome for this video is, I can simplify rational expressions in factored form. Okay, so as you can see on the screen, there are some important vocabulary words we need to discuss in this lesson. First of all, if we're trying to simplify rational expressions, we need to understand what a rational expression is. So a rational expression is an expression that can be written as a polynomial divided by a polynomial. If you see here in the word rational, you see the word ratio. Well, ratio means a fraction or a comparison of two numbers. So a rational expression is similar in that there is a fraction bar, and then if we just have a polynomial in the numerator, and remember a polynomial, we can talk about that term in a second here, is a monomial or a sum of monomials. So you'll notice 3x is a monomial. We're going to go back through these vocab words a lot in class as well. 1 is a monomial, and this is a sum of monomials, which creates a polynomial. All right, so there's a polynomial in the numerator, and if I wanted to put maybe a 3-term polynomial in the denominator, and therefore this is a rational expression. It is an expression that can be written as a polynomial divided by another polynomial. So a rational expression typically looks like a fractional situation. Now, to simplify them, we are going to simplify rational expressions. To simplify means to use the rules of algebra to rewrite an expression as simple as possible. And I know it's not usually good practice to use the same word in its definition, and it's close. It's not the exact same word, but we want to break it down or simplify it as far as possible. One way you've already learned how to simplify is just with a basic fraction. Let's say we have 3/6. We've learned that we can simplify this fraction because they both are divisible by 3. So we've done like 3 divided by 3 is 1, and 6 divided by 3 is 2, and we've simplified our fraction. And that is a lot like what we're going to be doing in this unit, but with more complicated rational expressions like this one. So we'll talk more about that as the lessons go on. The third word we want to make sure we understand is the word factor, and we want to talk about that in contrast with the word term, because these are the two things that people make a lot of mistakes with. So a factor is a number or quantity that when multiplied with another produces a given number or expression. And then a term is the parts of an expression that are added together. Now here are some keywords here. Term has the word added, factor has the term multiplied. This is going to be key. I'm going to use 3x to help us understand the difference between factor and term. Okay, so this whole thing, 3x, is actually a term. So I could rewrite 3x here as an example of a term. And if I, like, for example, added 7 to it, okay, a term is, 3x is a term in that expression, okay? Whereas if I used 3x, I would have to talk about 3 as being a factor of 3x, all right? So a factor is a number or quantity that when multiplied, look at between 3 and x, there's no symbol, which means it's being multiplied. So between 3 and x, there's multiplication. So 3 is being multiplied by x to arrive at our expression. So 3 is a factor. Guess what else is a factor here? Well, x is. X is a factor as well. It's just a different factor. So in this example, 3x has two different factors, 3 and x. Okay, so 3 and x are factors of 3x. Whereas term down here, like I mentioned, if I have 3x plus 7 as an expression, this whole thing is a term. So 3x is an example of a term because it's the parts that are added together in an expression. So what's another term for 3x plus 7? Well, 7 is. So 7 is also a term. So again, here, 3 and x are factors because they're being multiplied, and here, 3x and 7 are terms because they're being added. Okay, so now I know that that is a lot of vocabulary, and we have even more vocabulary on this page. But we're going to go ahead and take a look at a couple of rational expressions. You see one here and one here that are almost identical but that we're not going to be able to simplify the same way. Okay, so first of all, let's read this information at the top. To simplify rational expressions, and that's the goal for this standard, we're going to simplify rational expressions. To keep talking about our vocab here, rational expressions, like the word ratio is in there, so it's a fraction. So you got a polynomial on the top and the bottom with division in the middle. It's a rational expression, so is this. We're going to simplify it, make it as simple as possible. And to do that, we must look for and cancel, we'll talk about that word in a minute, factors that are common. Now that's the key right there, factors that are common to the numerator and denominator. So let's take a pause here for a second and not talk yet about the factors. We're going to come back to that in just a second. Let's make sure we understand this terminology here, numerator and denominator. So let's remember that a numerator is the top portion of a fraction. So there's the numerator at the top. And the denominator is the bottom portion of a fraction. Okay, so numerator is on the top and denominator is on the bottom. Okay, so back to this word factor. All right, we need to look for common factors that are in the numerator and the denominator. And let's remember that factors means things that are being multiplied. That is so important that you think about that, being multiplied. Okay, because what we see in the difference between these two examples, there's not much difference. The only difference is that between the 4 and the x, if nothing exists here, it is multiplication. And down here, what's between these, the 4 and the x here, is addition. What that does is that makes 4 and x factors in this rational expression, but it makes 4 and x terms in this rational expression. We cannot cancel out terms. We can only cancel out factors. So what we would be able to do in this fraction here is cancel out common factors or simplify our fractions. We learned long ago that 4 and 2, since they're both divisible by the same factor, which is 2, I can divide 4 by 2, and if I divide by 2, I get 2, and I can divide 2 by 2, and I get 1. Okay? I can simplify that rational expression because the 2 was a factor of the 4 and the 2. So then my answer here would be 2x over 1, which is just the same as 2x. Now down here, since 4 and x are being added, they are terms. They are not factors. Therefore, we cannot simplify this rational expression at all. One of the most common mistakes people make is they want to cancel the 4 and the 2, just like we did up here, and they want to say this is 2 over 1, and they want to say 2 plus x over 1, so 2 plus x. This is absolutely not correct, and that's a really big deal. We cannot cancel terms with a factor like this. This does not work. I want to talk really quickly about why it doesn't work. Let's say our value of x was, I don't know, make something up here, 10. If x is 10, and I started with 4 plus x over 2, and I said, let's say x is 10, then I put that in there, right? I'd get 4 plus 10 in the numerator, which is 14, divided by 2, and I would get 7. Now, our answer that we just tried to simplify all of this down to 2 plus x. Well, if I take 2 plus x right here, and I put in that same value of 10, then our answer here is 2 plus 10, which is 12. Did we come up with the same value for our answer? No. So that means that what we started with is not equal to what we ended up with here because it didn't come out with an equal value when we plugged in the same number. Okay? Whereas if I had done the same thing in this example up here, if I put 10 in the top here, so 4x over 2, and I put a 10 in right there, well, 4 times 10 is 40, and divided by 2 is 20, okay? And then if I do the same thing with 2x, because I said that this ends up being equal to this, so if I take that 2x and I put 10 in here, guess what happens? Well, that's 2 times 10, and 2 times 10 is 20. So we ended up with the same value when we plugged in 10 for this original problem and what we simplified it to. We came up with the same value. Again, down here, we did not. So this was not the correct way to simplify this over here. Again, the main thing here is we can only simplify by canceling out common factors, not terms. Okay, so let's take a look at this example of a rational expression here. We have 2 times the binomial factor x plus 3 times x minus 2, the binomial factor there, all over 3 times x minus 2 times x plus 5. And I said the word times a lot because, again, in between everything here is multiplication. You see those little red dots I'm putting in there. All of that is multiplication. Okay? Now, what's weird sometimes is people see this addition sign right here and they're like, oh, so we've got terms. Yes, we have 2 terms in these parentheses. 2 terms in the parentheses. But this as a whole, since it's being multiplied by 2 and being multiplied by x minus 2, this as a whole is also a factor. So x plus 3, for example, and this is the same thing for x minus 2 and x plus 5 and all that, okay, x plus 3 is a binomial factor in this rational expression. A binomial factor. Again, binomial, more vocabulary. Bi means 2, okay? So it's a polynomial with 2 terms, excuse me. Here are my 2 terms. X and 3 are my 2 terms. So this is a binomial factor because it's being multiplied by other things in the numerator here. So we can cancel out not only just numerical values, but we can also cancel out binomial factors. And if you notice in this rational expression, we're looking for a common factor in the numerator and in the denominator. So here's a factor of 2. Do I have a factor of 2 down here? Now the answer is no. Do not for a second think that you can cancel this 2 with this 2. This 2 is stuck in the parentheses as a binomial factor. You cannot cancel these 2's. Next, we have x plus 3 as a factor, a binomial factor. Can I cancel x plus 3? Again, you have to be able to cancel the entire binomial factor. Okay? No, there's not another x plus 3 in the denominator. Again, there's a 3 right here, but I cannot cancel this 3 with this 3 because although this is a factor, this 3 right now is not a factor. It is a term in a binomial factor. Then we have x minus 2. X minus 2 is a binomial factor. Do I have x minus 2 as a binomial factor in the denominator? Yes, I do. So I can cancel this entire x minus 2 with this entire x minus 2, and I will get a simplified result of 2 times x plus 3 over 3 times x plus 5. This is as simplified as our answer can get. We have no other factors that we can cancel out because there's no 2 factor in the denominator and there's no x plus 3 binomial factor in the denominator. Same thing goes with there's no 3 in the numerator. Again, this 3 is stuck as a binomial factor and there's no x plus 5 in the numerator. So here is our simplified answer. Now, this was a lot of vocabulary and a lot of introductory stuff on a trickier concept. So we are going to do a lot of discussion and practice in class. See you then.